All right, so the topic that we're looking at is bearings. So this is the last part of trigonometry. So we already did the trigonometric ratios, SOHCAHTOA. We did Pythagoras theorem. Those are mainly for right angle triangles. Then we also looked at cosine rule and sine rule. Now the last thing to bring it all together is bearings. So what we plan to do today, we try to understand the concept of bearing, which is important. That's the most important part, to understand what a concept is and wrap our head around it. Then we have to learn how to determine the bearings between a given point. And then we want to determine a length and or angle of a triangle based on information provided with bearings. All right, everybody got it? All right, nice. All right, so when we talk about bearings, right, we're talking about an angle in degrees measured clockwise from north. This is the important thing to remember. It is measured clockwise from north. So we have to always look at that angle when we are doing it from north, and it has to go clockwise. So you're not going anti-clockwise. So those of you who are left-handed, sometimes it's tempting to go in that direction, which would make it go anti-clockwise, but you have to remember we're going clockwise. Okay, so next thing about bearings are written in 3 digits. So you say, for instance, if we have a bearing of 40, we wouldn't just write 40, we would put 040. Okay, and the important thing is to always remember that we're going clockwise. Can't say that enough. So essentially, this is the example of what it looks like. So if you look at this here, we have a point A and a point B. So the bearing here would always come, as we said, from north clockwise. So if you look at this arrow here, we're saying, okay, A. We want to figure out what the bearing of B is from A. So bearing of B from A, which is our starting point A, is clockwise from north, 140 degrees. All right, so take this down, and then we start to go into this deeper to better understand what this terminology is saying, the bearing of B from A and all this kind of stuff. All right, so take this down. Bearings, we have to use our directions: north, east, southwest. So looking at this, the bearing from north going to east, what do you think that would be? How much degrees you think that would be from north to east? 90. Lovely. So if I say something is due east, I mean that it's 90 degrees from north. What do you think south would be? How about north? I want it from north. Remember, we always use it from north. 180. Excellent. We got 180 would be due south. What do you think due west would be? 270. Excellent. All right, so these would be the hard directions. East, 90 degrees. South, 180 from north. Due west, 270. Okay, so I want y'all to take this down. So anytime you hear a question making reference to a point as due east, it's due east. What it's telling you is that the bearing is 90. If it's due south, it's telling you that the bearing is 180. Okay, so these are the terminologies that we need to use in order to understand or make reference to bearings. What we need to understand is, what do we look at when we're reading bearings, right? So when I say from, that's stating the starting point. All right, if I'm saying to or of, that states where the bearing is going. So for instance, if I'm saying I'm traveling from Anguilla to St. Martin, I'm traveling from Anguilla to St. Martin. Where is my starting point? Anguilla. And where am I going to? St. Martin. So this is what we need to understand. So back to our diagram here. This says the bearing of B from A. The bearing of B from A. Where is our starting point? How do you know it's B? It's A. Why is it A? It says from A. So I must start from A, and it says the bearing of B. So if I'm saying of, it states where I'm going. Okay, so I'm going to the B. But where am I going from? I'm coming from A. Does that make sense? So I want y'all to take this down because this is very important. The two things that we looked at just now, the directions, the hard angles of those directions, and this particular terminology here, as in from, to, and of, is very important when it comes to understanding the concept of bearings. So when we want to draw the bearings, the first thing we need to do is draw an arrow pointing north at the point you are moving from. And then you have to draw a curve clockwise until the desired angle is reached. Now, how do we get this angle? We're going to be using approximations, right? We know where 90 is supposed to land. We know where 180 is supposed to land. We know where 270 is supposed to land. So because of that, that would give us an idea of where we should actually be when it comes to that. Okay, so in this case, for instance, this is 140. So we know right here, what angle would have been right here? 90. And straight down, what angle would have been here? 180. So we know 140 must land somewhere between 90 and 180. Does that make sense? All right, so take this part down and then we'll get right into it and start trying to draw some of these. Look at this first one here. It says draw a bearing of 60 from A. Draw a bearing of 60 from A. So if I want to draw a bearing of 60 from A, the first thing I need to do, draw an arrow showing north. Okay, so we're coming from the point A. So I already draw the point A and the arrow that shows me north. Now what I need to do is I need to figure out where 60 is going to land. So obviously we know that if we was to do this here, this would represent what? What angle would this represent? 90. So that means 60 must fall between north, all right, and this 90. So let's just say the 60 fell somewhere here. Okay, now what I would do in this case is write the angle from north going clockwise. Notice I'm going clockwise. Clockwise is this way. So my bearing here is 60 degrees. So notice how I drew the north arrow first, then I approximated where the 60 would land. Obviously 60 must land between 0 to 90. Okay, so that's what I did there, and that's what I have here. All right, so essentially it would look something like this. So we're saying that the bearing from this particular point, we draw north first, we approximate where the 60 would land, and then we draw the angle here to represent 60. So in this instance, we are saying that the bearing from A is turning at 60. We're just trying to understand and conceptualize right now where this is supposed to go and how we're supposed to do this, and then we keep building on this. So this is level 1. So right now we are on level 1. So I want y'all to take this down as an example, and then we'll keep advancing through this concept. All right, guys, so let's see if you do this one now. So the question says, question 2, we want to draw a bearing of 120 from A. Let's see what y'all gonna get from there. All right, so as soon as you get this now, send me what you did. Send me what you did. All right, we're looking good so far. Don't forget to label A as well too. All right, so we're supposed to look something like this, right? I see you guys got this, so this is good. This is what you're trying to do, because remember, we are doing it from the point A, and going from north, we're going clockwise 120. Now 120 is more than 90. Remember, that would have been due east. It's more than 90, but it's still less than 180. Okay, so we have to bear that in mind. All right, let's try the next one. So moving up the levels now. So draw a bearing of 220 degrees from A. Let's see what you guys come up with a bearing of 220 degrees from A. As soon as you get it, send it to me. All right, punch in. So this is what we have here. So we have the north line here, and remember, we're going from clockwise. So we go clockwise, so we always go this direction to get to where that point is. Okay, let's try one more on this particular level. Then we are jumping levels. We are going to the next level. All right, so check this out now. This is what it looks like. Y'all got it down pack. Y'all punching, man. Y'all on top of it. All right, so this one here is different now. So what we're going to do now is say the bearing of C from A is 150. The bearing of C from A is 150. So I want to ask the question, what is our starting point? Where are we starting from? So we are starting from A. We are starting from A. So if we are starting from A and we're going to C, or the bearing of C from A, what we want to do is the same concept that we was doing. So we expect the 150 to land between 90 and 180, but what we're going to do after is put a point here now saying that, after all of this, our point is going to be at C. So we are turning 150 degrees this way to get to the point C. All right. So this is level 2 of what we're doing. So this is my example to you. Let's just process that again. So it says the bearing of C from A. So the question is, what is my starting point? My starting point is A. So I want to make the angle or the bearing from A, because A is my starting point. So once I turn this angle 150 degrees, I know that C is somewhere along that line. For now, we haven't put the distance. That is something we look at in the next level. So let's see how we handle this one. All right, so for you to try, the bearing of F from G is 210 degrees. So you're asking yourself, what is my starting point? And then where am I going to? Where does the angle land? Let's see what you guys come up with this one. All right, so we're supposed to look something like this, but we can't forget our point F. We can't forget our point F. So the bearing of F from G. All right, so let's step it up a little bit here now. So level 3. So now we actually have to put a distance. Okay, so go through it, and then after give you some to try. So it says the bearing of A from B is 300 degrees. So I'm gonna work on doing that. That's the first thing I want to work on doing, just drawing that part. But when I'm done, it says the distance of A to B is 24 kilometers. So all I have to do is on that line write 24 kilometers. So we're adding one more step to what we have already been doing so far. So this here basically indicates the distance that is traveled and the bearing that is being done at. Okay, so our starting point, same concept, was from B. So we start at B and we do an angle 300 degrees. We draw a line like we was doing all the time, and then we make our point to say, that is A. And the distance of A to B is 24 kilometers. All right, so one for y'all to try. Let's see what you get for this one. The bearing of C from G is 40 degrees. Notice how I put the 40 here with 3 digits, okay? With 3 digits. So it says now the distance of G to C is 30 centimeters. Let's see what your diagram is by the end of this. All right, so it looks like we got it, man. So this is what we're gonna look like, something just like this. Just like this. Okay, so the next step now. This here, same concept. Y'all know how it goes. What's our starting point? X. And we're going to where?
G.
Lovely. And the distance between the 2 points would be?
5 meters, sir.
Yes, 5 meters. And the thing is, we know that the bearing always goes which direction?
Bearing? Oh, from north?
From north, and it goes what? What direction?
Down?
Clockwise. We're gonna look something like this right here. All right, so I think y'all got the concept sorted on this level, right? Now let's try to step it up. Okay, so you have to do the first one and then The second one is a continuation from the ending of the first one. So I'll take y'all and put y'all out in the sea to swim and see how y'all handle this one. So it says here the bearing of y from x is 160 degrees. You could do that. That's easy. So we are starting from where? Where are we starting from?
X.
X. And we are going to
Y.
all right, good. Now, once we establish that, the next thing we have to do is the bearing of z from y. So we started from x, ended at y, and now we're going from where? Y to z. So then now, y becomes our new starting point. So we have to do our bearing from y to get to z. Now, this is in words. I want to see how you would represent this on a diagram. So take a shot at it, see what you get, send it to me, and then after we're gonna go through it together, and then I'll give you a next one like this to try.
Teacher, I got a quick question.
Go ahead.
This here gonna go on two different drawings?
No, it's gonna be the same drawing.
Yeah.
You gotta do the bearing of y from x first, just like how we've been doing it all the time. So that first sentence is what we've been doing all the time. Now the
Okay.
second part, your new starting point is y. So what you're gonna do, you're gonna pretend that y was your original point, and you're gonna do the same concept you do. Draw a knot from y and do it again. Okay, so let's see what you come up with. Y'all got the general idea, man. Y'all got it, man. Y'all got it. So essentially, this is what it looks like, you see. So basically, the bearing of y from x is 160. So y from x is 160. The distance of x to y is 20. So here to here is 20. Now, this is where it starts to get interesting. We now have to do the bearing of z from y, which is 250. So from y, we're trying to get to z. So we have to do an angle here, 250. Okay? So here again, we write a new knot, and then we do the angle turn 250 clockwise. Boom. Z is down here, 30 meters. Does that make sense?
Yeah.
All right. So let's try our next one. And then we're going to use this particular one to show the connection for how this links back to sine rule, cosine rule, finding lengths, and finding angle. All right, so this is what we're supposed to look like right here. Boom. Okay, so notice, I see how y'all remember now to put the knot and turn at this point, which is really good. So that's how this is, so you understand the general idea and concept of bearings and how they work. Okay, corresponding and co-interior angles. Right, so we have two parallel lines here. So these blue lines are parallel. Now I have a random line running through this. So what happens is, when you have that, this angle is the same as this angle. Y'all ever remember seeing this before?
Yeah.
Okay, good. So therefore, these two angles here as well would be the same. Now I have a question though. What do these two angles add up to? Two of these would add up to what? 180. So two of these add up to 180. Okay. Now I'm gonna take this here now to show you a point. Okay. So we have this angle here, this question here. Now, before I even talk about this question, I want to dial back into us looking at these knot lines. So these knot lines are very important. Why do I say they're important? Because these knot lines represent the parallel lines, just that in this case they're on the side. So notice, if I was to draw this here like this being my north line, and over here this being my north line as well, it's safe to say that two of these lines are parallel to each other, correct?
Yeah.
Good. Now, if the angle inside of here is 130 degrees, so in essence, here's 130, what do you think the angle inside here would be? This angle here. what do you think the angle inside here would be? Right? Remember, if here is 130, we also know that out here would be 130 as well too. But inner part here would be 50 because two of these supposed to add up to 180. So if you look at this, between the two parallel lines, the inner one here with 130, the inner one here is 50. Both of them add up to 180. Now, I said that to say we want to figure out what is the size of angle XYZ. So we want to know what's the angle inside of here. All right. Now, based on our concept earlier, this 145 here is on this line, which is parallel to this. So if I was to draw an angle here, what do you think the angle inside of here would be? Well, both of these angles add up to what? Or these two here, this one here and this one here. 180. All right, so two of these should add up to 180. Everyone follows that? Good. So just to refresh your brain again, we have this here, a parallel line. These two angles here should add up to 180 because this angle here is the same as this angle here. So if here is 50, we expect here to be 50. And if here is 130, we expect this other end would be 130 as well too. So as you can see, this inner part, 130 and 50, they both add up to 180. Likewise, if we had it from here, both of these add up to 180. It's just a whole 180 story here. So in this case, if this is 145, the angle in here must then be 180 minus 145, which is equal to what? 35 degrees. Okay? So the angle in there is 35 degrees. Does that make sense?
Teach, you could do that over, please.
All right. So, I'm using the fact that I have two parallel lines. What are my parallel lines here? What two parallel lines do I have? My parallel lines in this case would be these here, these arrows. Okay, so I'll use this as a reference. I'll use an example as a reference. So let's say we have two parallel lines. So this is a parallel line. And we also have one here that's parallel. Now it looks like it's off because they are at lower levels, but essentially all of these are parallel lines, right? Y'all can see that?
Yeah.
Now, imagine we have a line passing through at this point here. So in this case, that line represents this here, okay? Now, I know that the angle here is 145 degrees, okay? Now, the fact that we have a corresponding angle, I know that this angle up to this point would be 145 as well too, okay? So if I was to extend this line here, I know that from here come across is 145, but I'm not interested in that right now. But I'll just show you here that it's 145, right? So this is 145 degrees. Now, if I'm telling you that this is 145 degrees and the red line is a straight line, what would be the angle inside of this piece here? If this is 145, what would be inside of here? This is a straight line. Straight lines add up to how much degrees? 180. So if this is 145, what should here be inside of this? Anybody could help me? What would in here be?
35 degrees.
35. How you know it's 35 degrees?
If you subtract 145 degrees to 180, you get 35 degrees.
Excellent. And now when I'm looking at these two angles here now, this angle and this angle, they both add up to 180. Now, why am I doing this? I'm just doing this to help me to kind of figure out what in this space is. My ultimate goal is to figure out in this space. So before I figure out this space, the only thing that I have that can help me right now is the fact that 145 is here, and then inside this little space here is 35 degrees. Now, if I know inside of here is 35 degrees, this has nothing to do with a bearing. This is no bearing here, because first of all, bearings only go clockwise. So this part is 35, and then from here to here is 240. Okay? So I just use my knowledge that two of these inner angles would be 180. So that's how I know that this 145 would make here 35. Alright, because 180 take away 145 is 35. Everybody understand how I get a 35 now? Alright, good. Now, a complete circle adds up to how many degrees? 360. So if I want to figure out the angle XYZ, meaning the angle in the middle here, Y, so XYZ, which means that I'm trying to find this angle. I now know that here is 35, here is 240. How can I work out this angle? How can I work out this angle?
Subtract 360 from 275.
Exactly. Now, how did you get 275?
35 plus 240.
Good. So 240 plus 35 gives me 275 degrees. Now to figure out what this green piece is, I know that this full thing here is a circle. So that's going to be 360 subtract 275, which gives me 85 degrees. So the angle inside here is 85 degrees. Does that kind of make sense what we're talking about here? So what I'll do is I'll go through it again. So let's catch the concept here. So I'm using the fact that the north that I drew are two parallel lines. So I drew two knots, this one here and this one here. Now, there is a line passing through those knots called XY. So if this angle here is 145, I know that the two inner angles here are supposed to add up to 180. So if I take this out for now, I know that two of these are supposed to add up to 180. So if I know that this here is 35, this is not a bearing, by the way. This is just me knowing that angle in here is 35. I could use that to manipulate the question to figure out what inside here is. Because if I know here is 35, I could prove it. And then here is 240. That must mean that little piece here, all these pieces have to add up to 360 degrees. So that's how I know that 240 plus 35 gives me the 275. And I subtract that, and this here is 85. So here's 85 degrees now. So when I add up 85 plus 35 plus 240, that would give me 360 degrees. Okay, so back to this again. So we're going over it again, reviewing it. So the first thing we want to do here, we know that here is 145. Now, I have two angles I could help figure out. I need to know what this one is, but before I figure out this one, I could figure out this little piece here. So I know that 145 here and this one here, these both should add up to what? What should these two add up to?
360.
No, the angle here. So this angle and this angle here supposed to add up to what? Two of these here.
180.
180. So if that's 180, here's 145. Inside here should be what? 35 degrees. Exactly. So then now, what do I do next to figure out inside the piece that I'm actually trying to find? So this angle here I'm trying to figure out. What do I do now? Right, correct. And then what do we do with that answer? Lovely. All right, so once we do that, we will get our answer, which is 85 degrees. Okay, 85 degrees. And y'all notice what shape this is starting to form? A triangle. All right, so the question is now, how can we calculate the distance of X to Z? We want to figure out what the distance is from X to Z. Now, this is where we start to bring up our other knowledge. Now, this here is a triangle. So essentially, if I was to draw this triangle and get rid of the extra information, I would have this here, where this here would say 85 degrees. Here would say 65 degrees, 65 meters, sorry. Here would say 70 meters. Okay? Now, the thing is, we have two lengths and an included angle. And we are trying to calculate the length of XZ. Okay, so this is tapping back into information and skills that we did before. So the question is, what is the length of X to Z? What is the length of X to Z? What do we do in a case like that? The length of X to Z.
The Pythagoras theorem.
We use Pythagoras theorem for what kind of triangles? Right angle. Is this a right angle triangle?
No.
Right. So what can we do to calculate the length? We have two options now, cosine rule or sine rule. When can we use each of those?
Cosine
So why would we use cosine rule?
has two included legs and no two included angle and two legs.
Excellent. So we have two lengths and an included angle. So we can now calculate the xz. So what we did here, this question first started off by giving us bearings, and then we had to figure out what the angle of the triangle is. That was our first step. Now the second step is to calculate the length. So it's like it's combining our different skills to see how we can use our tools. So at this point I know, okay, cosine rule, I need to have two lengths and an included angle. Now that formula is c squared is equal to a squared plus b squared minus 2ab cosine c. Okay, so c squared is equal to a squared plus b squared minus 2ab cosine c. Now, what is big C? Big C would be what?
The angle.
Excellent. So the angle is big C. So here is big C. So therefore, where is little c?
The length that we need to find.
Excellent, which is right here. All right, so who's going to be A and who's going to be B?
65A.
We could make this A, and therefore this would be B. So now we want to calculate the length of xz. All right, so if you remember, this is when we use the formula and go c squared is equal to 65 squared plus 70 squared minus brackets 2 times 65 times 70 times cosine 85. Y'all starting to see the link now? All right, so let's see how much y'all remember on how to do this. So I want y'all to calculate this and calculate the length of C. Okay, so let's try this one here now. So the bearing of y from x is 145. The distance of x to y is 65 meters. The bearing of z from y is 240 and so forth, right? So this is essentially the same question that we had here, but now I'm adding a little extra piece here. So here now we have this, and I'm saying that the bearing here is 30 degrees. Okay, the bearing here is 30 degrees. I just have one question. How can you work out the angle at this point here? What would be the angle here? If here is 30, what do you think the angle here would be? 180 take away 30 would make here 150. Excellent. So if here is 150 degrees, can we work out the angle inside of here? Do you think we could work this out? What we'd have to do? Wonderful. That's exactly what we would do if we wanted to calculate this angle, right? So just testing y'all out, just making sure that y'all remember the concepts. And then here now, if we needed to know what this angle is to help us find in here, how do we get this angle here? This will be the same 180 take away 145, which gives us 35. Okay? All right. So let's see now if we could combine all of this stuff to try and get a concept, right? So if I need to draw on this, I want you to draw on this diagram. So I'm giving you the diagram, okay? And I want you to put this on the triangle. So this is a question now. So what we are trying to do now, we're trying to combine everything. So at this point, we're trying to combine everything that we had so far. Okay, so for this question, it says x is on a bearing of 30 from y. Where's our starting point? Y. So the bearing of x from y is 30. So I should see a 30 here. Okay, now it says Z is on a bearing of 125 from X. So I want you to try figure that out too. And then it says X is 10 kilometers from Y and X is 7 kilometers from Z. Label this information on the given triangle. So I want you all to take this down and try to label the information that we have. So we have two bearings and we have two lengths. Then what we're going to do, we're going to try to put this all together in one question and do a whole combination of what we did here today in bearings, as well as the other topics that we were looking at in trigonometry, like cosine and sine and all of that kind of stuff. Okay, so I want you to take a look at this and try to label it. Then we go from there. So what we would have here now, it says 30 degrees, right? So the X is on a bearing of 30 degrees from Y. So X from Y. So our starting point is where? Y. Excellent. So we come here now and we make a little curve here. So this is Y and here is going to be 30 degrees. So we have this done now. So the next thing is Z is on a bearing of 125 from X. So this is Z and our starting point is X. So we're going from X to Z. So we always start from naught and we go clockwise. So from X, which is our starting point, to Z. Alright, so we're here now and this would be 125 degrees. Now, it says X is 10 kilometers from Y. So X is 10 kilometers from Y. So therefore, the distance here is 10 kilometers. Okay? Now the next point is, it says X is 7 kilometers from Z. So X to Z, which would be 7 kilometers. Okay, so we have again now, so X is 10 kilometers from Y. X to Y is 10. We got that. Boom. So X is 7 kilometers from Z. So X 7 from Z. We got that. Boom. Do you have yours labeled like this, guys? Lovely. Light work, right?
Yes.
All right. So let's see what's the next part. So the next part says determine the angle YXZ. Determine the angle YXZ. So we want to know the angle at X. So the first thing is determine the angle YXZ. Okay? So we want to figure out what the angle here is. So I kind of showed y'all a little hint earlier of how we could calculate this. Let's see how y'all gonna figure out this angle. So as soon as you figure it out, send it to me. So what we're doing now is combining all our skills with the bearings, the sine rules, the cosine rules. Let's see what we get for this. All right, y'all ready for us to try it? Let's try it together, right? So this here is 125. We already got this. We already got the 30. That's no secret. No. The only way I could figure out what's here is if I use my knowledge that, okay, here's 30. So this piece here, both of these added together should add up to how much, guys? How much should two of these add up together? 180. So if that's supposed to add up to 180, I know that 180 take away 30 is equal to what? 150. So if this is 150, here is 150 now. This puts me in a better position because now I know here is 150, here is 125. So then all three of these should add up to what? 360. So then I could say 150 plus 125 gives me 175 degrees. So then if all of them add up to 360, that means 360 take away 175 would be equal to 85 degrees. So here is 85 degrees. And as you can see here, we already have a triangle where we have two lengths and an included angle. So you know what the next question is going to be. What do you think the next question is going to be? We have to find the length now of YZ, right? And we can do that. Why can we do that? What do we have that can allow us to do that? So let's see what y'all going to do for this. So we have this angle now. We know that here is 85. We know that here is 7. Here is 10. We found out that this piece here was 125. we know that in here is 30 degrees. Let's calculate the length YZ. So we have two lengths and an included angle. We have two lengths and an included angle. So what rule can we use? Cosine rule. So we are trying to calculate this length right here. What is this length here? So we need to use this formula. C squared is equal to A squared plus B squared minus 2AB cosine C. So we are trying to find this C. So that is what we're looking for. We know that big C would be 85. 10 would represent what? A or B. And here would also be that. So then we will have C squared is equal to 10 squared plus 7 squared minus 2 times 10 times 7 times cosine 85. So let me see. I'll walk this out and see what y'all get. Right. So the way how you do it would have been, it just happened that the numbers work out to be that way. In another case, that wouldn't have worked. You see what I'm saying? So this is a concept you gotta use. You have to have, like, whenever you're doing something, you gotta ask yourself, can I prove this? So if you can prove it, you know you're on the right track. If not, you know that is something you gotta look into again. Alright, so let's see y'all work out this answer and see what y'all get. Alright, so with this part here, we know that C squared would be equal to 10 squared, which is 100, plus 7 squared, which is 49, minus, then we say 2 times 10 times 7 times cosine 85, which gives us 12.20. So here we will get 12.20 essentially. So then we will be left with C squared is equal to 100 plus 49 is 149 minus 12.2, which is equal to 136.8. So then now we have to find the square root of that. So the square root of 136 gives us 11.7 basically. So then C is equal to 11.7 kilometers. So here now is actually not unknown, it's actually 11.7 kilometers. The next part is asking us now to find what is the angle or the measure of angle XZY. So we need to figure out what XZY is. What is XZY? So this is very, very, very interesting now. Okay, so part 3 is what is XZY. So we need to figure out what the angle inside here is. Now we have enough information for us to be able to calculate it. Okay, because we could try to do our trick earlier that we was doing. So the angle inside here, we know what that would be. We could work out what this angle would be. How can we work out what the angle inside here would be?
Subtracting 125 from 180.
Exactly. So 180 take away 125 would give us this angle here. So the angle inside here, 180 take away 125 would give us 55. So here is 55. The problem is we do not know the bearing here. So because we do not know the bearing here, we can't use this to help us work this out. Okay, so that's our challenge right now. Okay, you don't know what this is. You can't prove to me what this is.
Teacher, if there's a circle on the outside and you don't got 55, subtract 55 from 360 to get 305.
Okay, you're right. You're right. But check this out. Remember, 305 goes all the way here. So this full thing is 305. But I want this little piece inside here. That's the angle that I need. Okay? I need to calculate the angle XZY. So I need to figure out what this angle here is. Now, since I can't use bearings to help me with that, I'll sketch it out so you could see what information we have so far. Let's see who's been practicing. Alright, so we know in here is 85. We know here is 10. We know here is 7. We want to figure out what here is. We don't know what here is, but we know what here is. How can we calculate this angle here? How? Hint, hint. Last class. Sine rule. Excellent. Sine rule. So this here is like saying small a, this here is big A, and then because I know this angle and I know this length, I could say, okay, this is small b, and here is big B or capital B. So therefore, I would say 10 over sine A is equal to 11.7 over sine B, which is 85. Okay? So therefore, I can start working this out. So I'll say 10 here over sine A is equal to, make sure y'all writing this down, because the next question, once this is done, I'm going to give you a question where you're going to have to try to do all of this on your own, okay, piece by piece. So 10 over sine A is equal to 11.7 divided by sine 85. So sine 85 is 0.996. So we know here is 0.996. So the thing that we have to do now, what do we have to do at this point? Cross multiply, okay? So remember, at this point, I don't even need this because this can't help me because I don't know what this is, okay? So I'm just here trying to figure out what this angle is at this point now, all right? So I cross multiply, that would be me saying 10 times what? What is 10 going to be multiplied by when I cross multiply? 0.996, which is equal to 11.7 times sine A. Okay, so right now, what I can do, I can multiply 10 to this, which gives me 9.96, and that's equal to 11.7 sine A. So how do I get sine A by itself now? Exactly, we divide both sides by 11.7. So if I'm dividing both sides by 11.7, I'll be left here with sine A. So then 9.96 divided by 11.7 gives me 0.851. Remember, we use 3 decimal places whenever we're using trigonometric ratios. So we say that this here is 0.851. So 0.851, and that's equal to sine A. So what do I need to do to calculate what A is now? Sine inverse. So I can say here now, sine inverse. Alright, so sine inverse would give me the value of A. So sine inverse 0.851, which is equal to A. So therefore, A is equal to, so sine inverse 0.851, 58.32 degrees. So that is the angle here. Okay, so just for ease of calculations, I'm going to use this as a whole number, to the nearest whole number, which is 58. So now I know what this angle here is. So obviously, if I know what this angle is now, I could calculate here also if I want to. All right, because all internal angles in a triangle do what? Oh, lovely. So I want y'all to take this down, and then after we go to the next part. All right, so let's see what the next question is up to. What mischief the next question is up to. So it says the bearing of y from x. So the bearing of y from x. Let's see who could figure this out. The bearing of y from x. We have enough information to do this. The bearing of y from x. Where is our starting point? We starting from where? And we going to... So I want to see y'all try to work this out. Let's see what y'all come up with. Just a quick note. We could have also used cosine rule to calculate this answer here as well to this angle. The reason why we could have used cosine rule is because we have all 3 lengths. And if you remember from our notes, we can use cosine rule when we have all 3 lengths. So if you can't remember that, you could refer back to that video just to make sure you catch that concept. Okay, so let's see what y'all get for number 4. Anybody answer it yet? So the question says the bearing of y from x. So where's our starting point? X, which is right here. And we're going to where? To y. So we make the drawing like this. We go clockwise straight around until we hit y. So if you look at this, we already know this bearing here, which is 125, and we know this other this angle here, which is 85. So this full bearing here therefore has to be 125 plus 85, which is 210 degrees. Okay? Make sense? All right. Next question. The bearing of y from z. The bearing of y from z. So let's put this angle here as well so we can know. So the bearing of y, the bearing of z, sorry, from y. The bearing of z from y. Interesting. So the bearing of z from y. Bearing of z from y. So I'll give y'all a little hint. This is what you want to work out. Let's see what y'all come up with. Nope. How you get 88? I just give you a hint. So let me show y'all. Because remember, this is just me throwing y'all out in the water, okay? When y'all do the next question, y'all gonna have an idea because we went through this, right? So check this out. We need to figure out the bearing that's going here. So we need to figure out what this bearing is here. Okay, what do we have already? What do we know about this bearing so far? What angle do we have already for this? 30 degrees. So what's missing?
The other angle.
This one right here. No. This is the one that we are missing. So how can we work out this little piece of the angle? So I'm going to take this out to make it simple for you guys, right? Let's take out all the extra data. And I'm going to put here 85. I'm going to put here 58. Now tell me this angle here. Can you see it now? Exactly. So we say now. Now y'all talking. So 85 plus 58, which gives us what? 100 and what? 43. So 143 degrees. So then now 180 take away 143 is 37. So 37 degrees. So inside here, this little red spot in here is 37. So if inside here is 37, so let me take this out now and put that inside here is 37. So if inside here is 37, what would the bearing be? 67. So the bearing is 30 plus 37, which is equal to 67 degrees. All right. So I want y'all to take this down because it coming, you know. It coming. It coming. The question, I'm going to give y'all a question after this to do on your own. It's coming. So make sure you take this down because this is going to help you to answer the next question on your own. The other questions on your own like this. I think we have one more for this one. Last one. The bearing of y from z. So we want this bearing here now. The bearing of y from z. So we want to work this out. So that's the last part for this. Bearing of y from z. So essentially, we want to work out what this bearing here is now. Right here. The bearing of y from z. Okay? Let's see what y'all gonna come up with. Alright, so let's go through it together. Anybody figure it out?
So you linked to it last time. I tell you 305 was the whole circle, right?
Mm-hmm.
But then we had one missing angle. So I subtract 58 from 305. and they give me 247. So the outside right here from not down to the beginning of 58 will give me 247.
Correct. Correct. So what happens now? That's good. Nice. So what happens now? We know 125, and then this angle inside here, both of them supposed to add up to what? What are these supposed to add up to? 180.
360. Wait. Oh, these two up top?
Yeah.
I thought you were talking about a whole circle.
No,
Never
just
mind.
these two. So 180. So we know here's 125. So when we subtract 180, take away 125, we get 55 degrees. So here is 55 degrees. So if this is 55 degrees, here is 58, we could work out what this here is. Because now we could say what? 55 plus 58, which is equal to 113 degrees. Now all I need to do is go 360, subtract 113, which gives me 247 degrees. So my bearing is 247 degrees. So right here is 247 degrees. And that's my answer. Make sense, guys?
Some kind of how, but yes.
Good. So make sure you got this, because now I'm going to put you on to a similar question, but you got to walk your way through it step by step, just like this. Okay? So let me show you the question. All right. So for this one, we're doing a similar concept. We have to determine the angle FGH. So let's see how y'all would get FGH. So before you do anything, you have to label the diagram. When you're done with that, you're going to calculate the length FH. So from here to here, then you're going to find out the angle of GHF, which is inside here. What trick are we going to use to figure that out? And then the next thing is, what is the measure of angle GFH? So this time we want to figure out what that angle is inside of here. Okay, just a little hint. Then it wants the bearing of F from G, and then the bearing of H from F. And then you're going to do the bearing of F from H. Let's see how y'all going to get this one done. All right, so let's start with the first one, right? So determine the angle of FGH. So FGH. Now we know the G is on a bearing of 25 from F. So G from F is 25 degrees. And then H is on a bearing of 100 from G. So our starting point is G. So from G, H is 100 degrees. So F is 2.6 from G. So this should be 2.6 here. And then H is 2.3 from G. So then now we need to determine the angle FGH. So we know that here is 25, and these two angles here, so this angle here and this angle would add up to 180. So therefore I could say 180 take away 25 is 155. So I know here is 155 degrees. Okay, so for part A, since I already know that that is 180 degrees, what I can say now is I add these up, 155 plus 100, because this whole thing here is supposed to add up to 360. This whole thing here is supposed to add up to 360. So 155 plus 100 gives me 255 degrees. Now when I subtract that from 360, I will end up with 105. Yes, degrees. Excellent. So this is 105 degrees. So now we need to calculate the length of F to H. F to H. So how can we calculate the length F to H? How can we calculate F to H? Cosine rule. Because remember, we have this triangle here. So here is 105, here is 2.3, and here is 2.6. Okay, so we're gonna say that c squared is equal to a squared plus b squared minus 2ab cosine c. Now the thing is, we are trying to figure out what here is. We have this, which is a capital C. Here is going to be A, here is going to be B. So we have two lengths and an included angle, which means we're going to use cosine rule. We can use cosine rule when we have two lengths and an included angle. So c squared is equal to 2.6 squared plus 2.3 squared minus 2 times 2.6 times 2.3 multiplied by cosine 105. Alright, so 2.6 squared is 6.76. 2.3 squared is 5.29. And we subtract that from, so this here we need to multiply this. So 2 times 2.6 times 2.3 times cosine 105, which gives us negative 3.1, you could say. So then when I work this out, notice how this here 6.76 plus 5.29 minus negative 3.1. So 6.76 plus 5.29 minus, now we have negative 3.1, which gives us 15.15. So that means essentially C would be equal to the square root of 15.15, which is 3.89. Or you'll get a number close to this. So this here is 3.89. So we worked out this first one, which is 105. We work out this one, which is 3.89. So the next part is, what is the measure of angle GHF? So for part C, we need to now know the angle GHF. So if I'm drawing my triangle back, just to make it easier for myself, I know that here is 105, here is 3.89 kilometers. I know what this length is, which is 2.3 kilometers. Here is 2.6. Now, I want to figure out what this angle here is. So I have all three lengths, so I could use cosine rule, but I could also use sine rule, which is a little quicker. So 2.6 over this angle here. So it's going to be 2.6 over sine A, which is equal to 3.89 over sine 105. Why doing making sense, right? Everything adding up together now, right? Now that I doing it is making sense, right?
Yeah.
Okay, so we could work out what sine 105 is. So we say 2.6 over sine A is equal to 3.89 over sine 105. So sine 105 gives us 0.965, but this 9 is going to make this 5 turn to a 6. This goes over 0.966. What's the next step?
Cross multiply.
Exactly. We cross multiply. So this times this times this. So it's going to be 2.6 times 0.966, which is equal to 3.89 sine A. So 2.6 times 0.966, 2.511. But look at this 1 here. So this here, 2. So 2.512. So 2.512, which is equal to 3.89 sine A. So how do we get sine A by itself now? We divide both sides by 3.89. So we divide both sides by 3.89. And that will give us the sine A. So let's see what that looks like. So 2.512 divided by 3.89, which gives us 0.457. This 7 will turn this to a 6, so 0.646. Okay, so now we do the inverse, sine inverse. So once I do that, that would give me the answer for A. So in essence, A would then be equal to 40.24. So here is 40.24 degrees. So I know inside here is 40.24. I could even keep it simple and just say 40 just for the sake of numbers. All right, so let's try D now. So D is, what is the measure of angle GFH? So now we have two angles. So here is 105, and we just worked out what here is. Here is 40. So what would be this angle here? How can we work this part out?
Add both angles and then subtract 180 from it.
Wonderful. So 180, subtract whatever we get when we add these up.
145.
Good. So in this case, 180 minus 145, which is equal to 35 degrees. So we know that here is 35 degrees. So we did this, we did this. So this worked out to be 40 degrees. This worked out to be 35 degrees. Now we have to work out E. So E, the bearing of F from G. So the bearing of F here from G. So what would that be? The bearing here would be what? What would be the bearing here? So the bearing of F from G. So where's my starting point? G. And I'm going to where? F. So from G going to F, I should get what? 205. So that means E is going to be 100 plus 105, which gives me 205 degrees. All right. Now, how about F? So F says the bearing of H from F. So the bearing of H, so this bearing from F, 60 degrees. How you?
I went from H. Sorry.
Good. So you go here now, because remember, its starting point is from F. So we look at where F is. F is here, and we're going to where? We're going all the way to H. So once we go like this, we stop right here. So this here would give us the 25 plus the 35. Okay, so F would be 25 plus the 35, which is essentially what? 60. But with bearings, remember, we write it with 3 digits. So 60 degrees is our answer. Okay, so we can say here this was 205. This was 60 degrees. Now, the bearing of F from H. So the bearing of F from H. So from here, go straight around here. All right, not clockwise. We always go not clockwise. This here is just to help us to figure out what angles be. So this has nothing to do with the bearing. So what would H be now? 240. Nice. So y'all see when we go through it together, y'all understand what's going on, because two of these here are supposed to add up to 180. So this piece here, both of these add up to 180. So if this is 100, here is going to be 80. Good. 80 plus 100 is 180. Now, I know that 80 plus 80, okay, so I'll work out G right here in its own little section. So 80 plus 40 gives me 120. So I know 120 is from here to here, but my bearing is always clockwise. So I go all the way around. So that's going to be 360 minus 120, which is 240 degrees. So then my answer here is 240. All right. Does that make sense, guys? Yeah. Lovely. So what you're going to do is just make sure you take this and go through it. Try to understand it. And then tomorrow, guys, feel like what we're going to do is we're going to try to look at it. This is question 3. So question 3, N is on a bearing of 146 degrees from M. N is due east of L. So N here is due east. So remember, we have the directions north, east, south, west. So what this question is saying is that N is due east. So if N is due east, what would that bearing be? What would that bearing be? Let's pull out a compass, right? So on a compass, we have north, east, south, west. Okay? So what is the bearing from north to east? 90 degrees. So if n is due east, so n is due east of L, that is telling us that here, the bearing here is what? The full bearing here would be what? 90 degrees. So that's what that means there. Okay, so it says n is due east of L, so that means n is 90 degrees away from L. 90 degrees, all right? So it says the bearing of M from L is 50 degrees. So the bearing of M from L is 50 degrees. Okay, so we have to look at that. Where's our starting point? Because it says the bearing of M from L. So from always tells us the starting point. So we are starting from L and going to M at an angle of 50 degrees. So the next thing says the length of L to M is 20 kilometers and the length of M to N is 16 kilometers. Sketch these on a diagram. So I want y'all to sketch these and see if you can label them with this information. Once you're done, we'll try to do it together. And then we'll look at answering some questions. So the other questions we want to look at on this particular question is, we want to determine the angle LMN. We'll do this together. We want to determine the angle NLM. We want to calculate the length LN. We want to measure the angle LNM. We want to find out the bearing of L from N. And we want to find the area of LMN. All right, so let's go through this part now, okay? So the first part that says N is on a bearing of 146 from M. So my starting point is M and it's going to N. Remember, bearings always go clockwise from north. So I have my north line here and I'm going clockwise. So I go like this, which gives me 146 degrees right here. And that's because N is on a bearing of 146 degrees from M. So N is 146 from M. That was my starting point. Does that make sense?
Yeah.
Now the next part says the bearing of M from L is 50. So my starting point, it says from L. So I'm starting from L and I'm going to M. So then the bearing would be right here, which is 50 degrees. Okay, now the cool thing about this due east is that I could figure out what this angle in here is. So who could tell me what this angle in here would be because of the due east? 40. Excellent. That's just because it says due east. In the questions that we did before, remember, I did not have due east, so we had to walk those angles out. Okay, so that is the most important part for y'all to remember. In this situation, we can do that because it says due east. Once you have anything saying due east or whatever the case is, we know for sure that's a solid 90 or 270 or whatever the case is. All right, so we have that. So the next part that says the length of L to M is 20. So that was easy stuff. L to M is 20, so we just label 20 here. And then from this one, it's 16, okay? Because it says M to N is 16. Okay, so this is the thing now. We want to determine the angle LMN. So LMN, that means the angle is right by the M. So L to M to N, that means our angle is right here. This is the angle that we're trying to calculate. Now, any ideas as to what we could do to calculate that angle?
Teacher, which angle?
The red one.
Okay, so if each line, right, is 180, 180 degrees, L already has 50.
Okay.
That would mean subtract 50 from 180. You get 30. 130. So that angle right there is 130. Then you add up 130 and 146.
Okay. Pause. Okay, let's take a little break there now. All right, so you guys following what he's saying? You following the process he's doing?
Yeah.
Okay, I know he's going quick, but we just trying to keep up. All right. So we got it now. We understand how we get this. So 130, we know that this is 130 here, right? No. Everybody understand that. So what's next now, Justin?
Add 130 and 146.
So 130 plus 146, which gives us
276.
276. Okay, what to do now?
Subtract 276 from 360.
All right, so 360 minus 276, which gives us
I calculate that part yet. 84.
84. Nice. So that's our answer. 84 degrees. Good. Good job. So this here is 84 degrees. So y'all understand what he did there, right? This is the similar concept to what we did yesterday. Y'all follow that, right?
Yeah.
All right, good. Now it gives us a next one. Determine the angle N. Okay, N, L, M. So the angle right inside here. Somebody already did that. N, M, L. What would be our angle inside here? 40. Great. So essentially, here is 90 minus 50. Now the only reason we know that is because we know that this is 90 degrees only because it said due east of L. N is due east of L. So this is N, which is due east of L. So we know this full angle here is 90. So that's how we were able to work that out. We didn't guess and say, "Bye, that looked like 90." We knew it was 90 because they told us. Okay. All right. So the next part says calculate the length of LN. So we want to calculate the bottom length here. How do we go about doing that? So far we have two lengths. Why sine rule?
We got two known angles.
We got two known angles. Yes. Y'all got a good point.
Cosine rule.
I did not say it. The other one was not right.
Oh.
But you, okay, let's say this. Let's say this, guys. Both answers are correct, right? But I want us to talk about now why they are correct and why they work. Okay? So, the sine rule. Let's talk about sine rule. Everybody done start talking about sine rule. Why can we use sine rule in this case? Somebody had started earlier, and in fact, we're going to do both ways. Okay, so check this out, right? We got two angles here, right? Correct. 40 and 84. You understand? That's good that you guys spot that. That's really good. Very impressive. So we have two angles and we have a unknown length, but we also have two lengths. Now, if I'm using sine rule, which is A over sine A equal B over sine B, right? So what we're going to do now, we're going to say A is, let's say A is 16 because we have that, and this is going to be capital A. So then here is going to be B, and this is going to be capital B. So then we're going to have 16 over sine 40, which is equal to, we don't know what that is yet, B over sine 84, okay? So then we're going to get 16 over sine 40, and what is sine 40? 0.643, right? And that's going to be B over sine 84, which is 0.995. What do we do here now? Cross multiply. Nice. So then now we got 16 times 0.995, which is equal to B. Let me put a number first. So 0.643 B. All right. So how do we get B by itself? We work this out first. Let's work. Yes. We divide by 0.643. But let's work out the values. So that's 15.92, which is equal to 15.92 equal to 0.643 B. All right, so divide both sides by 0.643, and the answer is 24.76. Okay, so 24.76 kilometers. And just to prove the concept in this particular case, guys, in this particular case, I can use sine rule because I had two angles and a length, but I also had another length, but I'm having this missing length here, right? So that's all I need to use sine rule. But I can also use cosine rule because in order to find the length for cosine rule, what do we need?
Two lengths and an included angle.
Two lengths and an included angle. Music to my ears. All right, so we're trying to get at, we got two lengths and an included angle. So that means I could use c squared is equal to a squared plus b squared minus 2ab cosine c. Let me see. So c squared, let me label these. So we got here capital C, and this here is a, b, right? So I could say c is what we're looking for right here. So c squared is equal to a, which is 20 squared plus 16 squared minus 2 times 20.
So we finding that the angle now?
The length.
Oh, so this gonna get us 24.7.
Supposed to.
Okay. Okay.
Because remember, the two rules could work in this case, huh?
Yeah.
All right. So 20 squared is 400 plus 16 squared. What's 16 squared? 320. 256.
So one of them, 256.
256 minus. So if I put this in the calculator, it's going to give me 2 times 20 times 16 times cosine 84 is going to give me 66.9. All right. So then I could say c squared is equal to, when I add this up, it's going to be 400 plus 256, take away 66.9. All right. So that gives me 589.1. Now, I need to find the square root of this. So the square root of this is, drum roll, 24.27. So you see it a little off, but it's like right there. So it's close enough for our liking, right? So all you need to do is show your ability, right, to be able to calculate it. So you know that the information they give you allows you to get this answer. So if you notice here, obviously what happens here is that once you got like cosine 84, sine 84, sine 40, the rounding of these values is what alters the minute values on this side. Okay, but generally you can see it's like about 24, 25 range. All right, so y'all see how we could use, in this case, either two of these, any one of these, to answer that question.
Yeah.
All right, good. Now, part D. Part D here. What is the measure of angle LNM? So we want to figure out what this angle here is. All right, so we got two ways to calculate this one now. And you know why we have these two ways, guys? Because of this 90 due east situation. Only because of that. Notice when we did questions 1 and 2, we could not do that, okay? So in this case now, for part D, we could add these up like a triangle, okay? So we could say 40 plus 84 gives us what? It gives us 124. Then we could say 180, take away 124. So in this case, we end up with 56, right? So here is 56. But anybody remember how we could do it from this part here? These inner angles supposed to add up to what? 180. So this here now would be 146. So 180 take away 146, which is 34. Good. And then here to here, it adds up to what? 90. So then 90 take away 34 is 56. Boom. Make sense?
Yeah.
Good. So y'all take this down, and then we're going to talk about the last two questions.
But teacher, then would always be looking for a definitive answer, or just based on how you work it out?
Based on how you work it out, because you see, as you could see in the sample that we did over here, remember, if I chose to do sine rule and you chose to do cosine rule, our answers will be slightly different. So they could be watching your process as well too. You see what I mean?
Yeah. But just asking because I see the answers is fairly similar, but if in the instructions they don't say how to do it,
correct. Because if they don't give you specific instructions as to what to do, that's how it is. You see what I'm saying? Nice. All right. So anybody could tell me the bearing of L from N. So the bearing here from N. So if it's going from N, we expect N going to L would be this angle here. So let me see if y'all could figure out what that angle would be. Maths is cool stuff, you know, real nice, interesting stuff.
270.
Lovely. 270. That's it right here. That is it right here.
You get that quick because of the 90 degree angle on it.
Of course. This piece here is 90. Okay, so this piece here is 90. So if here is 90, that means this here is going to be 360 minus 90, which is 270 degrees. Make sense? Good. All right, so F. Who remembers how to calculate the area of a triangle, so LMN, when we do not have a perpendicular height? Who remembers? We use the sine form of the equation, half AB sine C. Y'all remember that?
I don't remember that.
Okay. Remember when we did sine rule? Y'all remember when we did sine rule?
Yeah.
That same day we did it. Okay, so you gotta go through it, right? So check this out. Now, if you look at this, right, I could say that this here is C because that's an included angle. Okay, big C, included angle. And here is going to be A and B. Remember, C would have been here. But remember, we could do it all kind of ways, because in this particular situation, we have all lengths already. Okay, so let me use 24.76 for instance, right? We could have used this as an included angle and this as A and B. We could have used this as an including angle and this as A and B. Okay, whatever you decide to use, it would give you about the same answer, right? So it would be a similar situation to like how this was. Okay, so what I would say here is half AB, so half times 20 times 16 times sine 84. So half, so that would be 1 divided by 2 times that by 20 times 16 times sine 84. Okay, so 159.12. Right, so then we would have here the area is 159.12 kilometers squared. So that there would be the area of this triangle. All right, make sense? Y'all follow that? All right, good. So that is question 3. We're gonna try now this one. Okay, you're gonna have to determine the angle ABC after you get all this sketched information, and then determine the length of AC, which is very straightforward, and prove that the bearing of A from C is 270. So all you got to do for that last part is show your calculations to show that it's 270, similar to what we did earlier. So this is our last question, and then after we work on the activity for this. So it says C is on a bearing of 130 degrees from B. So from B, we have C on the bearing from B 130 degrees. So you guys should have 130 here. Do you have that? Nice. And then it says, so tick for that, C is due east. Due east tells us that it's 90. Always remember that, okay? The only time you got assume something is 90 is when they tell you that. So the next thing says the bearing of B from A. So we turn in from A. That's our starting point, A. Here would be 55 degrees. Now they say the length of A to B is 7.8. And then the length of B to C is 6.9. All right. So that's a sketch. See how it looks? Y'all got this, right?
Yeah.
All right. So let's go to this angle now. So we know here is 55. These two angles here, 55 and this, should add up to what? 180. So then after we could say the 180 minus 55 gives us 125. So right here is 125 degrees. Okay, so then now we could work out the angle in here. How can we work out the angle in here? All three of these angles should add up to what?
360.
Exactly. So 125 plus 130 is equal to 255 degrees. So then I could say now 360 minus 255, which is equal to 105 degrees. So here is 105 degrees. Okay, now for B. So B, we have two lengths and an included angle, and we could also figure out what this angle is just because, you know, we know this is 90. But using cosine rule, I would say that we have two lengths and an included angle. So this is capital C here, and this here is AB as we so desire. So C squared is equal to 7.8 squared plus 6.9 squared, because remember, it's c squared is equal to, I'll write back the formula, a squared plus b squared minus 2ab cosine c. So then we say minus, open brackets, 2 times a, which is 7.8, times b, which is 6.9, times cosine 105. And because this is more than 90, it's going to give us a negative number. So c squared is equal to, so 7.8 squared is 60.84. 60.84 plus 6.9 squared, which is 47.61. So then we could say 7.8. Okay, I'm back now. You're back. All right, good. So 2 times 7.8 times 6.9 times cosine 105 is equal to negative 27.8 what?
6.8. Oh, yeah, 0.86.
Nice. So negative 27.86. So then remember, this part is going to turn to, we add this here. So let's add this first. 60.84 plus 47.61. So 108.45. So then now we minus in negative. Remember, once we have a negative, minus a negative, we got to turn to a what?
Positive.
Exactly. So you got to end up adding once we do that. So 27.86. So we gonna get 136.31. So then we find the square root of that, and that would give us our answer. So c is equal to, what's it gonna equal to?
11.58.
Right, 11.68. So we could put here 11.68 kilometers, and that's our answer. Wasn't too bad, right? Y'all got this? Nice. Then for C, we prove that the bearing of A from C is 270. So we know here is that, right? So we want to prove A from C. So this is A from C. So it's going to go like this. Okay? So this angle here is 90 degrees. How do we know that? This said due east. So if here is 90 degrees because of the north, that means going back this way must also be 90 degrees. So then I could say 360 minus 90 degrees equals 270 degrees. And that's our answer right here. Okay? So for this, we have our answer, and for this and this. Okay, guys? So this is basically how we go about doing this. All right? So I want y'all to take this down, and this is stuff to go over and practice and go step by step to see what's happening, so you can better understand how things merge together, right?